in, let's say 2023, 2024, the way most people were trying to build agents is a human designs a system, and that system kind of breaks the problem down into multiple steps. It assigns each of those steps to an LLM. Maybe there's some rules built in, but oftentimes, like the real world is messy, and that workflow that you built might be an oversimplification of the actual process. A real expert at this task would follow. And when models are able to learn how to do the process by being rewarded for succeeding at the process, they're able to figure out, in many cases, something that's better than you could easily sit down and design yourself.
All right, everyone. Welcome to another episode of the TWIML AI podcast. I am your host, Sam Charrington. Today, I'm joined by Josh Tobin. Josh is a member of technical staff at OpenAI. Josh, it is great to have you on the show. We last spoke, can't believe it's been over 5 years now.
That's amazing. Yeah.
It is
The time
amazing. In
flies.
fact, yeah, I think it was, I think we spoke in Vancouver, like right on the tail end of NeurIPS or during the NeurIPS
I think
there
that's right. Yeah,
in 19.
I had a paper there that we were talking through.
I actually have it noted here, geometry aware neural rendering.
Yep. Yep. Yeah, that was actually my the last thing that I worked on and my last stint at OpenAI before rejoining again in September.
Awesome. Awesome. Well, you've done a few things since then. I think full stack deep learning was one of the things that folks may have heard your name pop up on, and then you were working on a startup. Tell us about what you've been up to over the past few years.
Yeah, so I left OpenAI back in 2019 and co-founded Gantry. We were a machine learning infrastructure startup, and when we were kind of thinking about sort of where to take that business uh, at the sort of middle of last year, ended up kind of through a bunch of different circumstances winding up coming back to OpenAI. And here I've been leading the agents research team. So our team builds the models that power our agentic products like Operator and Deep Research and the Codec CLI, which we launched a few weeks ago.
And we're going to spend a bit of time talking about agents and those agents, agentic products. I'm curious in thinking about Gantry and what you were doing there. And um, I think Gantry was in kind of a crop of ML infrastructure, ML ops companies that uh, I think ran into this, like, all of the air getting sucked out of the room by Gen AI. Like, I'm curious if you have any takes on that space and like how it relates to, what we're all trying to do with Gen AI now.
Yeah, absolutely. I mean, I think it was, in the pre ChatGPT era, I think a lot of companies' mental models was that um, every company is going to need to be training models. Um, before we had GPT-3 and later models that did this more effectively, the thinking was like the way to create actual value with AI is to train models that are fit for purpose for the thing that your business needs to do. Um, and so there's a whole kind of like category of infrastructure that was built under the assumption of like every company is going to be, every business out there more or less is going to be training its own models in the future. And so what tools will they need? I think what turned out to be true is that general purpose models, GPT-3, GPT-4, other large language models are, are like quite good at most tasks that you can specify. For any given domain, you might be able to build a better model than GPT-4, but it's going to be pretty hard and pretty expensive. And if there's an off-the-shelf model that can just do those things well for you, it's so much faster, cheaper, more efficient to build, like to what every business needs to build on top of that, like commercially provided model instead of, building up all the infrastructure expertise and data and sort of domain specific knowledge that you need to in order to build the model yourself. And so I think that kind of um, didn't fully invalidate, but it made the business model that a lot of that crop of ML infrastructure startups was thinking about a lot less feasible. Because, now I think my operating assumption is like when I advise companies on how to think about ML, I generally tell them don't even think about training your own models until you've exhausted what you can do with the models that OpenAI or any other foundation model provider will sell you.
Yeah, that's absolutely a smart approach. I recently wrote an article that reflected on a paper that I wrote back in that 2019 timeframe, and I called out this idea that I thought that I got both right and wrong. Like the core idea was that uh, in order to be competitive, businesses would need to become model driven. Like this core idea of uh, pulling patterns out of data and putting them into kind of operational workflows in order to make decisions faster and more accurately than humans could was like a key element of what ML was offering folks. And I think, businesses being model driven is even more true. But the idea that like everyone was going to build those models themselves, as you just noted, turns out to be less true because of foundation models, right?
Yeah, and I think and you're starting to see kind of a crop of CEOs now, you know, publishing their thinking and the way that they're kind of urging their companies to use AI internally. And so I think that is like absolutely true and is actually coming true now. That there are important companies that are um, sort of uh, walking the talk when it comes to adopting AI and making it a pretty core part of a lot of what they do, which is kind of like what we all hoped or thought was going to happen back in the day. It just happened a little bit differently, I think, than maybe some of us anticipated.
Yeah, I think you're referring to tweet X that went viral by Shopify CEO. I forget his name. And he talked about kind of trying to drive urgency among their teams to adopt AI internally. And I think, that maybe sets the stage for one of the things that we want to cover in this conversation, which is like what it's going to take to make agents real more generally. I think the presupposition is that, we're not fully there. Like they do a lot of interesting things, at least when bounded by, whatever appropriate scope. But I think the general vision of, my sidekick agent that, sits there waiting to or even anticipating my needs and then going out in the world and operating on my behalf without constraint, we're still a bit of ways from there. Yeah. How do you think about what agents are really good at today, relative to what we might want them to do?
Yeah, I think we're closer to that than it seems. Um, I think that the misconception that a lot of folks have about agents is before I came back to OpenAI, had spent a little bit of time tinkering, building agents on top of LLM APIs, and the problem that we ran into, which I think is the problem pretty much everyone runs into when they try to build their own agents, using like workflows on top of LLM API calls, is that um, it's very tempting to think, oh, LLMs are good at kind of making point predictions, making decisions, and so we build a workflow around this LLM, then we can sort of automate a process and take a bunch of decisions and turn it into something that just happens on its own. But I think what a lot of us found trying to do this is that um, the temptation is there because you can create a demo of this very, very quickly. That looks great. Um, but then when you try to actually deploy this and get people to stop doing this work themselves and instead delegate it to an agent, you start to run into all kinds of edge cases and uh, failure modes, and getting things to work reliably is really hard. And sort of the root cause of the problem is that LLMs, most LLMs, historically have not been trained to do agentic work. And what that means is that at any given step of the process, maybe they're relatively accurate because they're pretty smart general purpose AI systems. Um, but as you run a process that requires many steps, the small errors at one step compound as you take multiple steps. So even if you're 90% accurate on one step, if you have to take 10 steps, then your accuracy will fall off. Um, and so that's, I think, kind of the core challenge of um, building agents on top of traditional LLMs. The missing ingredient has been that we need to directly train these agents end to end to do these workflow like tasks. Um, by doing that, you can train the agents in such a way that they see failures during their training and they learn to recover from those failures. So even if each step is only 90% accurate or 95% accurate, now the model has seen what it looks like to fail at that step and it's able to reroute itself. It's able to think, oh, this doesn't look right. Like, let me go back and try that again. Um,
Do you have a canonical example that kind of illustrates this problem?
yeah. So a good example of this would be like if you are, or if you're trying to kind of like build an agent that um, does research for you. So if you um, if you do a single web search and maybe you get the search term wrong, like the user doesn't know exactly what to search for, so you try to search for terms that seem relevant, and you start to pull back a bunch of docs that don't have information that really gets to the heart of the problem. Um, then a naive agent might just get confused by that, and it might think, well, okay, that I searched for the term that I thought that they meant, and all these docs are irrelevant. So maybe this is, you know, maybe what the user asked for doesn't make sense, or maybe I need to go down this other rabbit hole. Whereas an agent that's trained to do web research and has been uh, trained using reinforcement learning to sort of uh, be good at this multi-step process, will in its training have seen many instances where it searched for the wrong term, and the training has incentivized it to learn to recover from those instances, and instead go back and think, oh, I searched for this term, but I got results that weren't relevant. Maybe that means that I had the wrong search term. So let me go, try again and pick a different one. And so the key is really like um, reasoning models, power that are trained end to end to solve the kinds of tasks that users need them to solve using reinforcement learning, so that they're able to kind of like see these multi-step processes, see the kinds of failures that happen in training, and learn to recover from them.
It strikes me that the creation of models that are specifically designed to do this is one powerful difference that we're seeing in this new generation of models, but also it's like a collapsing of capability, uh, a bunch of stuff around the model that was trying to like keep it in the right path to just like making the model better. Um, you know, the deep research, I forget the name of the paper, but there was a paper that kind of proposed this deep research idea really early on. And it was like, a multi-agent system with one agent that, figured out search terms and the other agent that like reviewed the results and kind of rated them. And, there were several agents in this loop and they would ultimately write, whatever the report is. The impression that I get is that as we're training these models to more directly take on these tasks, we need less, it becomes less of a multi-agent type of solution.
The way I see it is like in let's say 2023, 2024, the way most people were trying to build agents is um, a human designs a system, and that system kind of breaks the problem down into multiple steps. It assigns each of those steps to an LLM. Maybe there's some rules built in, and there's two problems with that. The first is the compounding error problem that we talked about before. But the second is just that, like, I think I'm borrowing this idea from an old idea from Andre Karpathy, but like, uh, good models are just much better at us than designing these types of systems. Um, and so, you can kind of imagine how you want to break the problem down and think through the steps that you might take to do it. Um, but oftentimes, like the real world is messy, and that model that you built, that model that you built, that sort of that workflow that you built, might be an oversimplification of the actual process. A real expert at this task would follow. Um, and models are able to when models are able to learn the process, learn how to do the process by being rewarded for succeeding at the process. They're able to figure out, in many cases, something that's better than you could easily sit down and design yourself.
When you think about that, um, when you think about applying that idea, broadly among, developer teams writing software and startups and enterprises, like the ability, as you alluded to earlier, like the ability for OpenAI to create a model that's designed to do these things that improves these things is very different from, a startup or, enterprise academic institution. Like, I guess part of the question is like, do we just have to wait or like, what can we do now to build more robust agents?
No, you can go use, like, real working, actual useful agents now. I mean, deep research, I think, has been incredibly useful for a lot of people. It's, people are using it for, kind of like, business and research workflows, but also, scientific research, um, travel and shopping, programming,
Sure.
and
And
yeah, and it
not to
and
take
yeah.
away at all from deep research or codex, but like research and writing code are two of like many, many problems that I have or might want to tackle with agents. Like, do you, how do we get to a more generalized, uh, agentic model that, um, is easier for, your users to, build their own models with? And, maybe so that's the general question. Like a sub question is like, is that, GPTX or OX or whatever? Is it, are all models going to, get better at agentic capabilities? This, error correction, instruction following kind of melee that you just referenced, or should we expect to see like agent specific types of models?
Well, I do think it's, very much like as the models get better, building these types of workflows will be a lot easier. Already, I think O3 is, like, quite good compared to older models at being able to kind of understand the level of complexity of instructions that you often have to automate a process or build a complicated workflow. Um, and it's better at, um, adhering to those instructions and using tools over multi-step trajectories than anything else that came before it. Um, I still think there's ways to go before that is a generally useful agent. But I think that, yeah, as the models get better, um, building custom agents is going to get dramatically easier.
Are there characteristics of the models like, is it always going to be the case that you need a certain size or complexity of model to do agentic things well? Or, can these types of behaviors that we're talking about like be distilled into smaller models just as easy as kind of the core language fluency that, we've been able to distill into smaller models?
I don't think we've really exhausted our limit to of how good we can make small models. But I think the advantages that large models have are that, large models tend to be better at generalization. So if you're and most of the time, if you're building something custom on top of models, that thing might not be something that the developers of the model anticipated. So, um, larger models will tend to work a little bit better. Um, and I think the other feature of models for, agentic use cases that's really valuable is reasoning, um, because a lot of agentic, tasks have this quality where you there's a range in difficulty levels of solving the task, and, um, doing the right thing at each step of the task is very important to make sure that the overall task succeeds. And so letting the model choose, um, how much reasoning effort it wants to apply to figure out the current step of the workflow, to me feels like a pretty important component of of what's gonna make these systems work well.
And is that particular aspect new in O3 relative to O1? I've noticed with O1, like, um, it was a solid reasoner, but it reasoned for the same amount of time or on the order of the same amount of time all the time. Whereas O3, like, can give you a snappy ish response, but also take a bunch of time to think through things.
It's not new, but we're continuously getting better at making models that are smarter and knowing how much to think.
So I cut you off when you were talking about deep research and some of the ways that folks were using it. Like, I think probably everyone listening like gets the core value proposition thesis behind deep research. Are there things that you find that surprise folks that it can do that folks might not know, or are there examples of how folks have kind of pushed the edges with it?
Yeah, I think it, I think when people think about deep research, they think about using it for um, market research and scientific literature review and kind of other tasks where um, the model just has to go out and think and read a lot of documents to come back with a synthesized answer. But some of the other things that people are using it for, which were initially surprising to us, are coding. So it turns out, even though we didn't really design the model for this use case, um, there's a lot of code like publicly available on the internet, and the model, because of the capabilities in the base model, the model is able to understand it very well, and it's able to search and kind of like find code on GitHub and um, understand how different pieces of the code base work, and come back to you with descriptions of the code or plans for how to implement a feature or things like that. Um, and then I think the other kind of underrated use of deep research is for kind of finding very rare facts on the internet. Um, so I think people like probably the bulk of what I think most people use deep research for is going broad and then synthesizing. Like, find a go read about this topic and come back to me with a summary like covering these points, where the model has to like go touch a bunch of different topics. But the model is also quite good at finding information that is just kind of buried in the corner of the internet somewhere. Like if you have a question about, um, if you really want to recall like the details of some television episode that you saw a long time ago, where you know maybe it's something specific enough that it wouldn't just be on the Wikipedia page. Often the model will be able to find kind of that like one fan page or something like that from 10 years ago and point to that information too.
Yeah, even 4.0 is really good at that. Like, I'm trying to imagine how obscure you have to get in order to go to deep research for that kind of problem. Uh, and remind me, deep research is not accessible via an API currently. It's only via one of the surfaces.
Mhm.
Okay. Is that anticipated?
We found that mostly the kind of use case that we were imagining for deep research was kind of you're in ChatGPT for something that you normally use ChatGPT for, and then you there's something where you just really want a much more thorough answer than you get out of the box with ChatGPT. That's kind of the use case that we designed it for. Um, but you're right. I mean, there's a lot of other things that you could use it for, where having an API would be useful.
We talked just a second ago about kind of the spectrum of compute that you might want to throw at a response, and how O3, for example, can kind of start to manage that. Like at some point, I might want the model to just know if my question calls for deep research and just do it, right?
Yeah, that would be the dream, right? Like I think the thing that I would love ChatGPT to become um, is a place where you can just go and it's like talking to your friend and your coworker and your personal assistant and your coach all in one. To where you can ask a question like you would to a person, um, and just like a great coworker would, it knows, you know, when to come back to you with a really quick answer off the top of its head, versus like from the context and from knowing you, when it should actually go and do a bunch of research and come back to you with something more thorough, um,
Well, or both. Like,
or
here's
both.
my
Yeah,
initial impression, but I can go research that for
yeah,
you.
exactly right. It's like, yeah, here's the answer off the top of my head, but like I'll go dig into this a little bit more. Um, or it could, come back and like in deep research, there's this phase in the beginning where it'll ask you a few follow up questions, but um, I think eventually it should be able to just come back to you in the middle of its research and say like, "Hey, here's what I'm finding so far. Um, I'm going to keep going, but is there any feedback? Do you have any feedback on this? Is this what you're imagining? Or are there any, now that you've seen this, are there any other avenues that you want me to explore?" Um, so I think like evolving ChatGPT into an entity that feels a lot more natural to co-work with is one of the main things that I hope we're able to achieve.
You mentioned the follow up questions that happen at that initial phase of deep research. Can you talk a little bit about how explicit was like building that or tuning the model to do that?
Yeah, what we found is that deep research is, since it's designed to go deep and collect a lot of information and come back to you with a very detailed report um, that is really excellent at like covering all the finer points or the nuances of the the sort of initial framing of the question that you wrote. The quality of the results that you get are very sensitive to. Um, they're not very sensitive, but you get better results if you put time up front into thinking about what you really want to see at the end. Because the model is very good at adhering to those things, and it's very good at like knowing how to incorporate the like the different parts of the question that you asked into its search. And so the model will also come back with reasonable answers if you kind of just fire off a quick question to it. Um, but the upfront sort of back and forth is meant to help flesh out a more detailed thing to run by the model because we think it produces more compelling results.
Okay. Um, and was that an emergent, phenomenon? Like you train the model with an angle of like producing good results and it figured out that it needed to ask these follow up questions, or was there a degree of direction in there that I don't know how you might do that? I mean, yeah, any number of ways you might try to do that.
Yeah, the upfront questions were something that we added kind of after the fact, as like from observing the way that users interacted with the model.
And, I know from experience, you can suggest that you're not sure how to frame the question and that you might want some, you can prompt it to, you know, ask you questions and that works just
Yeah,
fine as well.
yeah, and one thing that we've seen a lot of people do is to use O1 or now O3 or O4 Mini to help craft the question. So if there's a topic where you don't even really know enough to frame a good question, a lot of times folks will have like a conversation with a smaller model, and then they'll use that to sort of flesh out all the details of the question that they want to research, and they'll put that into deep research and have it go, spend 10 or 20 minutes coming up with a much more researched response.
Um, so deep research was the first uh, agentic offering
Well, we also
from
have Operator.
OpenAI. Is that
We also have Operator.
operator? You consider that an agentic system?
I do. Yeah, I think of an agentic system as any AI system that um, is able to go work on tasks for you that take like longer than a few seconds, and that has to interact with the real world in order to solve your problem. So yeah, Operator, Deep Research, and Codec CLI, I think, are all good examples of agentic systems.
Got it. So let's talk a little bit about operator. I tend to think of it primarily. I've not used operator actually. Like I've thought of it as like a computer use analog, but it sounds like it it's a higher level system that you interact with and have it do. I mean, I've seen demos and that's the way it was presented, but I thought that those were demos of an underlying API as opposed to a service that I might want to use.
Yeah, no, Operator is it's also a service inside of ChatGPT. And so you can go to Operator. There's a link to it from ChatGPT, but it's a separate kind of web app that works a lot like ChatGPT. And so you can type in a request of something that you want to do, book a restaurant reservation, let's say, um, and then you can kind of watch in a virtual browser um, the agent kind of navigate to the web page, kind of click around the web page, and do the task that you asked it to do. So it's really really cool. It's like super fun to watch because it's just you can kind of feel the intelligence and the thinking as you watch the model like click through the web much like you would.
Are you finding that there are folks that are using it productively versus education and entertainment?
Yeah, absolutely. So, Operator, I would say, is like, I I the technology to make Operator work really well is, um, incredibly difficult thing to build, and so, Operator, is not intended to be the thing that, every single person in the world uses every day on day one. It was meant to be kind of like an early launch of this technology so that people, could get value from it and could also just get a feel for where this is going. But despite that, there are a bunch of people who do use this a lot, um, for, who like power users. I think of it a lot like kind of, um, like early GPT-3 API, if you remember that, right? Where it's like you people use it and it was, I don't think OpenAI would have framed it this way at the time, but in a lot of ways, it was kind of a technology preview. Like, it was something where most people tried it and they were like, "Oh, this is really amazing. It's amazing that humanity has created this thing." Um, but, they didn't immediately find it useful. But, um, even on day 1 with GPT-3, there were a bunch of people where, they were just really drawn to the technology and they tried it. They played around with it a lot, and they got to the point where they figured out how to make it really useful for them. Um, I think Operator is kind of more at that stage of model development, um, where, like, there are power users who love it, um, but it's not for everyone yet.
Yeah, that is my impression as well. It's not surprising to hear you put it like that. I've seen some examples of like, I think the theme that I've seen the most is like arbitrage. Like, I'm going to, have this operator find a bunch of stuff on eBay that I can sell for more on Craigslist, or like find Airbnbs and like message all the hosts to try to get a discount or something like that. Like, I looked at them and I was like, they were novelties, but maybe someone is actually doing that for, or something along those lines for, something that they think is useful.
Yeah, you can get a lot of value from it, if you sort of put in the work to figure out how it's useful for you.
Yeah. And then beyond figuring out how it might be useful for you, are there kind of non obvious ways to make it useful? Meaning, I've got my use case, like, how do I need to think about the world or my problem or operator in order to, make it work?
Yeah, so one thing that, I found to be really helpful for getting the most value from it is, there's a way to add sort of, site-specific instructions, add or customize site-specific instructions. Um, and so, if you're, imagining, operator visiting a website for the first time, it's kind of like you're, you're seeing this website for the first time without any context or with a very limited context of the world or who the user is, and so there's like a lot to figure out. But you can provide instructions that, help the model understand how to use this site to solve their problem, and, that tends to make it like a lot more repeatable and a lot faster.
So, like, don't just say, click upload in the menu, say, the menu's the hamburger thing on the right and upload. Like, how granular do you need to, first of all, are we talking about, uh, localizing capabilities on, the page? Or are we talking about other types of context that is useful for the agent? And then how granular does that tend to need to be?
Yeah, I think it depends a little bit on the site, and, sometimes it takes a little bit of tinkering to get it exactly right, but I find mostly just, like, helping to clarify the intent. Like, "Oh, if I wanna, um, if I want to, book a flight, here's how you do that," that kind of thing.
I guess there's Codex is the third agent in the portfolio, and with Codex, the Codex CLI. Codex has been around for quite a while. I think I when did I talk to Greg about the launch of that? That was August 2021 when we
Yeah, yeah.
caught up
This
about
this
that.
is this is a different codex. We're reusing the name.
But it's not intended to be. There's no underlying model.
I think the original codex was like the first, kind of code completion model. Yeah. Um, and so this is like a throwback to that name, but a very different model. Um, and yeah, codex is our, local code execution agent, and so it's just a package that's like fully open source that you can install on your laptop. Um, and then you can talk to it and you can ask it questions about your code. Um, you can or you can ask it to implement things in your code base. And this agent is able to use your computer to navigate the file system, find the relevant files, understand how they work, um, write code on its own, apply those patches to your files, run tests, try things out, and come back to you when it has an answer to your question or um, you know it's written some unit tests or it's written some code or whatever you really want it to do. So I think it's a really powerful like demonstration of where I think um, AI systems for coding are going. And people are loving it so far. I mean, people at OpenAI use it a ton. There's like more than 20,000 stars on GitHub, which is amazing to me. Um, we've got like around 100 people have contributed to it. Um, and so I think like a lot of people are kind of feeling the magic of it.
In a world where you've got Cursor and GitHub Copilot and Windsurf and maybe hundreds more of coding agents slash IDEs with coding plugins, like what differentiates Codec CLI, Claude Code type of experience from those others?
Yeah, I would say most people, most software engineers here use Codec CLI um, and potentially like some AI powered functionality in their IDE. Um, they're they're kind of used for slightly different things, I think. The IDE functionality is great because when you're inside of the IDE, um, well, when you're writing code, you're most of the time inside of the IDE anyway. And so those tools are amazing for just having like very quick access to the AI system, like in your flow state. Um, so if you're kind of like, if you're in the middle of writing some code, you can get a suggestion or you can, delegate something to a model and then just keep going with what you're doing. These agentic tools are better for like or at least I find myself and a lot of folks find themselves using them more for like de novo type work, where you, maybe you're just at the start of the project, or you're working in a code base for the first time, or you have an idea for a feature that you want to build that is not like literally the thing that you're working on at the moment, but it's something that you might want to delegate to someone else. Um, that's when like this agentic paradigm becomes really powerful because today the way the Codec CLI works is you can you give it a task to do um, and it just does it on your laptop. One of the really cool things about it is that it's able to do it in a network sandboxed way, meaning that it can just go and kind of work for you in a way that it is safe because it's not able to, it's not hitting the network and so it's not able to accidentally uh, run some unsafe command or something like that. Um, but I think over time, the um, but it's still kind of like running on your laptop, and so you still need to have your laptop open and sort of watch it as it goes. I think over time, like where this is going is that interacting with these coding agents should feel more and more like delegating to someone, where um, they're able to they're able to take larger and larger chunks of work and execute them more and more autonomously to where you can just, if you have like 10 things on your to-do list in the morning, um, maybe you go work on one and then you come back at the end of the day and the other nine have been finished for you. So that's kind of like, I think the paradigm of agentic coding and, we're not there yet, but where we're trying to get to.
When I think about the idea of it being best for de novo types of projects, I think of, okay, we've got these three classes now. We've got the cursors and the like. We've got your V0 bolts, which I think of as like de novo web. And now the Codex CLIs of the world are maybe like de novo backend or something like that.
I guess when I say de novo, I don't necessarily mean the whole project is de novo. Actually, one of the amazing things
Or it could
about,
be a feature,
yeah,
right?
yeah, a
I guess
feature
is
or,
what you're saying.
yeah, just something, where it's distinct enough from what you're like literally the code that you're typing right now, um, that it's worth kind of like starting a new thread for yourself to, to start working on this independently.
With that in mind, I was going to raise a question around context. One of the really interesting things that I've seen recently that helped me understand things that I've experienced is this idea that like when you're interacting with uh, AI assisted AI assisted code generation tools and IDEs, like one of the things that they're uh, you know, limited by and doing is like managing the context of, that is ultimately passed to the LLM. And that's why you get, different results between like just typing in a prompt in Cursor, for example, and, versus copying your whole file and, putting it into ChatGPT or whatever, chat model you use. And, uh, yeah, it's been suggested by some that like one of the things that these kind of CLI based agents, do better somehow is context management. Like, is that true? How do you think about context in this context and the role that it plays in development tools?
Yeah. Yeah, I think that, like, the, Codec CLI is you can almost think of it as, like, a contextless tool, um, where my mental model for giving a task to the Codec CLI is it's kind of like you're giving, a task to uh, like a superhuman intern who has never seen your code base before. Um,
That's only a little oxymoronic.
yeah, um, an intern because, you can't really trust it yet with, like, really, really complicated stuff that, where you need a lot of, state or a lot of, experience working on this particular type of project, where there's, a lot of different pieces that need to be broken down. So, I think you kinda wanna delegate, like, intern-sized chunks of work to it. Um, Superhuman because it's able to read code, write code, understand coding patterns, uh, much faster than any human can. Um, and seeing your code base for the first time because, um, it is contextless. And so when you start a new task in the Codex CLI, um, the model has to explore the code base on its own before it can start working on the task. Um, and the way it does it is pretty amazing. It's not using any kind of bespoke, um, context management tools or ideas. It's just using the same command line tools that, um, people have been using for decades
Yeah, like you'll
to
see it
explore
said
to
files and stuff like
exactly, yeah,
that.
to explore the file system. And, it turns out, which is, I think, really surprising, in some ways, that the model is just able to build an understanding of how to navigate the code base and how to, find the information that it needs and where to write code and what the patterns in the code base are extremely quickly just by doing that. Um, and the the coming back to the what we were talking about before of, like, the magic of, um, training models using reinforcement learning, to achieve an outcome. I think this is kind of like the type of magic that emerges when you do that type of training, is models, are able to learn how to use tools really effectively to achieve their goals. Um, and so my impression is that these models are much more efficient than humans are at, like, um, how much code they need to read before they're able to actually build something. Um, so that's, that's kinda how I think about context for these models. But, um, that being said, I do think that we could improve on this by, having like, giving the models, um, more context or or having richer customization. Um, so right now there's a way to, uh, customize the behavior of the models by sort of placing a file in the repository. But you can imagine all kinds of other types of customization too. Like, you can imagine giving APIs or MCPs to the model. You can imagine giving the model memory so it can remember things between rollouts. Um, these are lots of ideas that we're kind of exploring for how to make the models kind of even better at understanding the specifics uh, of your code base and, like, get smarter as they interact with it more.
And how do you think of Codex, particularly with it being open source, like in the spectrum of, research preview, here to get you thinking, to, first steps to something that reflects what, we ultimately want to deliver?
Um, yeah, I think the open source piece is, like, really critical to how we're thinking about building codecs. So we're very much like trying to do this the right way as an open source project. We're kind of building with the community. We're accepting tons of contributions from folks. I think there's like around 100 contributors now, um, and so we are like uh, we have sort of opinions and a vision for where we want to go with it, but we're also um, letting the community kind of help guide the direction that we uh, take with it. In terms of like readiness, like Codec CLI is really useful now. Yeah, people at OpenAI use it all the time. And I think a lot of folks, kind of a lot of the early adopters, have found a lot of success with it. I think especially with O3, um, it's able to just kind of like solve a lot of sort of, smaller, medium pieces of coding work that might have taken you a lot of time to do otherwise, or might have just been really hard because you don't understand that part of the code base, or, you know, it's some front end work and you're a back end engineer, or vice versa. Um, so yeah, people who are using it are getting a lot of value from it.
One of the complaints, if you will, is about like cost and cost opacity with using these tools. Everyone's mile's gonna vary in terms of value, but like, how do you think about that? How do you see, is that an area, or uh, is that something that you anticipate evolving over time?
Yeah, I think like if you look at the history of models, the cost has been falling pretty dramatically. Um, and also, I think we're in the early days of the um, Codec CLI is brand new, because the models have only recently gotten good enough for this to be a really good experience. We're also in the early days of model capability. Um, as the models get better and more consistent at producing high quality results, the cost is not going to matter as much because I think already in many cases, um, it's saving people a lot of time, um, and so uh, like paying a few dollars to save you hours is, depending on what you're doing, is often a very easy trade to make. Um, but but yeah, I think also like if history is any indication, I think it would be reasonable to predict that the cost will also come down.
Yeah, yeah. I was trying to get a sense for whether the predominant like trend or answer to that question is, the cost is just going to go down naturally like we've seen, or yeah, we hear that and we're going to be creating more visibility like, oh, that request is going to cost you 42 cents.
Oh yeah,
Um,
that's a cool idea too. Yeah. Um,
have you seen integrations with Codex CLI and other systems like Slack like or Devon like Slack interface or something like that? Like, does the open source aspect lend itself to folks doing kind of interesting things in connecting it to other systems?
yeah, I mean that's one of the things that we really hope is going to happen, and that's part of why we decided to open source it. Um, I think that there's um, a lot of places where you can imagine just programmatically triggering a coding task to start happening. So, one of the obvious ones would be in CI. Like if you have a build that's failing, or um, some tests that aren't passing for whatever reason, um, we've seen people starting to build Codex CLI into their CI workflows, to try to take a first pass at automatically fixing those issues. But there's all kinds of other things where it's like, oh,
Or
there's
even
kind
an
of like an
issue
automated,
posted, like
yeah,
give it the issue test and, what might be causing this?
yeah. There where you have like some kind of like feed of potential coding problems that are coming through. And you know, uh and the kind of like with deep research as well, like I think that primarily what people use these tools for initially is to do work that they just otherwise would not have done. Um like if you're kind of a busy software engineer and you have 10 things on your to-do list, um maybe you're only going to do 2 or 3 of them. And that's not that the other 7 aren't valuable. It's just that they're kind of like below the cut line of what you can really realistically prioritize. Um, and so, I think that's the thing that I'm most optimistic about using these agentic tools for in the near term is just kind of like doing all the stuff that you want to do and that would be good to do, but you just can't you can't do as a person with limited time.
Yeah, the intern analogy I think is the most popular, but I always like the sous chef analogy. Like, there's this thing that I'm really good at. I have my recipes, whatever. But like, don't make me cut the carrots. Like, just give me the chopped carrots, and
Yeah, that's true.
let me do
Yeah,
my thing.
that is another place. That's another place where we've seen people use the Codec CLI a lot. Is like, yeah, doing the kinds of engineering work that you just don't like doing. Um, Again, yeah, oftentimes I see this with like, back end engineers who don't like writing JavaScript, or very like product oriented engineers who don't like doing a bunch of data plumbing stuff. Are very happy to just, sometimes you have to do that stuff for your work, and so makes people happy to be able to have the model take a first pass at it.
Yeah. What do you think are the biggest things on the horizon that are going to change the capability of these coding models? I think folks who have used them, maybe let me ask this question, kind of the same question, but let me ask in a very different way. What's your take on the whole vibe coding thing?
I think that we are in the early phases of a dramatic shift to the way that software is built, where, um, look, I don't think writing code is ever going to go away. Um, you know, but I think that the process of manually writing code, where you have to write down kind of every single line of code yourself and manually test it, and um, think through the architecture, and you know, uh, kind of do each of these pieces by hand, is going to become rarer and rarer. Um, I think that most code, I think the vast majority of code, um, is going to be written by AI systems much sooner than people think. And I think the job of developing software, um, is going to become a lot more like, um, thinking about the functionality that you want the system to have, thinking about the trade offs, thinking about the edge cases, um, guiding the AI system, providing feedback to it, um, finding ways to validate its work. So I think that just the nature of the work is going to change, and people who write code are going to become much more productive.
Some of those tasks that you outlined sound like engineering tasks, but some of them sound like product tasks or product manager tasks. Do you think that this new world precipitate some kind of shift in the relationship between those roles?
I think that it is part of a shift that's already happening. Where like I think the as as programming has moved up, um, in abstraction over time, the ability of one person to kind of bridge the entire like span of programming has gotten bigger. And so we're already seeing the proliferation, especially in the startup world, of like design engineers, like folks who are great designers and can also build the things they design, or like technical product managers, um, or full stack engineers who can like write front end code and back end code. Um, so I think this kind of accelerates that, where um, it's going to be less of your engineering skill set. I think is still really valuable, but less of your mental energy will be devoted to kind of like learning the nuances or the ins and outs of a particular framework or um, language, and more of your mental energy will be devoted to thinking about how things work, what they do, why we do things a certain way, how do we know it's working well, and so that gives people space to think about a bigger chunk of the problem than they did before.
Do you see that the way people acquire those new era skills is different than how they've acquired them in the past? School and on the job experience? Uh, are there
That's a good question. I mean, I think that the by the far the best way to learn any subject now is using ChatGPT and O3 and deep research. Um, it's amazing because it's like you have access to, you know, um, effectively a world expert in many domains, that can spend infinite time with you and can get to know you really well. And there's no question that's too basic to ask it. Um, so I see how people learn these skills changing dramatically, regardless of this phenomenon. Like I think it's I think it'd be much easier to learn programming now with ChatGPT than it was to learn programming where when you didn't have access to a tool like this.
But though we're pointing to like learning programming isn't necessarily learning programming, it's learning architecture and patterns and all these other things. I don't think that changes your point that ChatGPT can be a great resource for learning these things, but there's also this element of like what it is to learn.
Maybe this is like a controversial opinion, but I still think it's important for people to learn programming, even if it's a smaller percentage of what they're going to spend their time doing. If you want to build software, because it's kind of like I don't know, like in grad school for machine learning, there's like kind of some of these rites of passage type activities, um, like building a computer from scratch, um, or uh, building a backpropagation library um, from scratch from first principles. That like okay, is this the single thing that you can do that will make you, that will like maximize your ability to perform your machine learning research or your machine learning job uh, the best next week? No. Like, you don't really 99% of the time when you're doing machine learning, you don't need to understand the way that propagation works at a very fundamental level. Um, However, like when things go wrong, um, being able to kind of spelunk all the way down the stack and think through like, okay, well, this isn't working. Why isn't it working? Having like fundamental understanding of pieces lower in the stack is really important to being able to do that efficiently. Um, And so, I think, like, a lot of people who have gone through that exercise will tell you, like, "Oh, yeah, every once in a while, actually, I do have to kind of, like, think about this, and I do realize, like, this is where the bug came from, is something about the way that backpropagation is working." And I think that, you know, um, the same will be true for code for a long time, where, like, if you aspire to be really good at this, um, there will be a lot of cases where, being able to look at the code that the model wrote, even though you'll do it less and less, is still very much worth your time. And the people who are able to do that well will be better at this like more vibe coding style of coding than the people who can't.
Makes me think of me spending years in grad school learning how to model MMKQs and never really using that, but I am great at picking lines in grocery stores and airports.
Yeah, these weird skills that we pick up along the way, right?
We've talked a little bit about, or at least you mentioned it, MCP and tools and the role of tools and, uh, you know, working with and building agents. Like, what's your take on that landscape? MCP is, maybe 6 months old and like really no one paid attention to it for, 3 or 4 of those 6 months. And now like everyone's building an MCP server and like it's become a really hot topic.
Yeah, and it seems to be really taking off. Um, yeah, I mean, I think exposing tools to model, like, if you think about the formula for useful agents, in my mind, it's like you have to have a really smart sort of general purpose reasoning model, um, and then you have to expose it to the tools it needs to do the thing it needs to do, um, and then hopefully you should provide a relatively small amount of high quality task specific training to teach the model how to do the thing that you want it to do. Um, and and so being able to expose the tools to the model in a way that it's able to use them both for training and also for um, doing the task in the real world is like a really critical piece of how the ecosystem fits together. And so I think, yeah, I mean, everyone is thinking about this now for good reason.
And are there obvious gaps to you that, MCP or some other protocol or even just best practice um, needs to fill in order to kind of bridge this gap between tools and agents?
One thing that feels not fully developed yet is the ability to um, specify a level of trust for the agent using certain tools. Um, so, for example, like I think um, the future that everyone is picturing is you'll just ask ChatGPT to go book a vacation, and it'll know you really well, and it'll go do a bunch of research, and it'll come back, and it'll just charge your credit card, and it'll like send you the itinerary. Hopefully asking you a bunch of questions and stuff along the way, if it needs to. But um, the act of like doing something like using your credit card is a very high trust act. Um, and just kind of exposing your credit card to an agent that you don't trust, or exposing your credit card to an agent without um, specifying how you wanted to use that and when you wanted to use it is a very scary idea, um, and potentially super risky. Um, so one thing I feel like the field doesn't have a great handle on yet is, um, yeah, how do we kind of like build in that kind of like uh, ways of specifying and enforcing certain levels of trust between the human, the agent, the tool, and the task, so that you can kind of like go just ask the agent to do something, and it knows kind of when it needs to come ask you for permission to use certain tools based on your interactions with it so far.
Do you have a sense for what that looks like? And I'm asking because, like, we want to, I think, build these models, based on, data and training and not, heuristic and, systems and like, the Carpathian analogy you used earlier. But it seems like, we've seen the research that says that, the models will kind of misrepresent their thinking and thought traces and like disregard instructions. Like it seems like there might need to be some extra verbal way of enforcing these kinds of constraints.
Yeah, I think at a fundamental level, what it comes down to is having a set of guidelines that you can provide to the agent about when it needs to come get your permission to use certain tools. Um, and so the most strict version of that would be like uh, so it's providing the guidelines and also having some mechanism to enforce the guidelines, or like some level of trust that the guidelines will be followed. Um, so like the simplest example of this would be like if you have a guideline that says um, you have access to a credit card tool, but every time you call the credit card tool, you need to come ask me to approve. Um, then you don't need to have a lot of trust in the model to use that tool, um, because you always will have the opportunity to review what it did. Um, Now there's still problems of deception because the model might try to represent what it did or what its goals of using the tool are. Um, but at least you have the opportunity to say no.
You still have to have a high degree of trust in the agent, even if, you specify, um, some set of parameters. And I think it's an interesting question whether, the current, you know, model of, the current crop of models or model architecture or the way we train models or the state of alignment like warrants that trust.
And it depends on the task. Um, it depends on the model. And so I think like building that trust to do high risk actions um, will need to be something that model developers think really carefully about, product developers think really carefully about, and um, users will need to build that trust. Even after all that, users will need to build that trust iteratively through interacting with the model. Um, and so, I think um, I think there's still a lot of thought that we need to do as an industry to figure out how to make that work well.
It's funny that you use that example because, like, maybe an hour ago, Harrison Chase posted about, CEO of LangChain, posted about some some news with Visa. They are partnering with Visa on Visa Intelligent Commerce, which is enabling AI agents to shop for you. And, in their little, this I think is a mock up, but like there's a slider and you can say what your max spend is. Um, but my response to that tweet is Visa going to allow me to like do a chargeback when I tell the agent that I want X and it buys Y? Uh, yeah, I think, um, that's both kind of pointing out the timeliness of this conversation, but also the fact that there are like technical and political solutions to the problem. Like, actually, a visa is going to be like, take the role of providing some degree of trust by allowing me to beat them up when the agent does stupid things. That could be interesting and useful as well. I don't think they will, but
Um, yeah, I mean, there will be residual risk there, and so I do think there is an interesting question of like, to what degree do these different parties should different parties bear that residual risk? Like, is it a risk that I just take on as a user? Is it something where like the model provider is sort of saying that it's okay? Maybe the payment provider.
it'll be certainly interesting to see how it plays out. Well, Josh, it has been wonderful catching up and chatting about all things agentic in your world.
Yeah, great to catch up.
Appreciate you taking the time.
Thanks.
Thanks so much.